Now that we know a little bit more about exponent properties and log properties, we're going to use these in order to solve some exponential and log equations. So we're going to start with the exponential equations. And there's two different ways that we can solve these, using the one-to-one property of exponents and then also using the definition of a log. So we're going to start with the one-to-one property. All right, so our one-to-one property of exponents says that if b to the power of x is equal to b to the power of y, then x equals y. So basically, if you have two exponential terms that are equivalent to one another with the same base, then the only way for this to be true is if the exponents are also equal. So if they have the same base, then they also have the same exponents. So we're going to be able to use this one-to-one property to solve equations when either they already have the same base or if we can rewrite both sides of the equation with the same base. So let's go ahead and look at some examples of using this property. All right, so our first one we have is 5 to the power of x plus 1 is equal to 25 to the power of x minus 3. Now, obviously, right now, we don't currently have the same base on both sides. The left-hand side has a base of 5, the right-hand side has a base of 25. But we are able to rewrite both sides with the same base because 25 is a power of 5. So what we can do is we can rewrite 25 as 5 squared. All right. Now from here, we can simplify. Remember, when we raise one exponent to another, we multiply them together. So that would be 5 to the power of 2x minus 6 on the right-hand side. Make sure to distribute your 2 into the whole x minus 3 term. So now we have the same base on both sides. Both sides of this equation are a power of 5. So according to our one-to-one property, since we have the same base on both sides, we can set the exponents equal. So this just becomes x plus 1 is equal to 2x minus 6. And from here, this is just a simple linear equation. So subtract an x from both sides, add a 6 to both sides, and we come out with x is equal to 7. And that's our final answer. All right, so this one-to-one property is going to be useful anytime we can rewrite both sides of the equation with the same base. Let's go ahead and take a look at a few more examples. All right, so our next one is 81 to the power of 2x is equal to 1 over 27. All right, so again, when we look at this, we definitely don't have the same base yet. We have an 81 on the left, we have a 27 on the right. But we're going to be able to rewrite both sides as 3 to a power. Okay, all right, so on the left-hand side, we can rewrite 81 as 3 to the power of 4. And then on the right-hand side, we can rewrite 1/27 as 3 to the power of negative 3. All right, well then, we again have an exponent raised to an exponent, so we can multiply those. This would become 3 to the power of 8x is equal to 3 to the negative 3. So now we have the same base on both sides, which means according to our one-to-one property, we can set our exponents equal. So 8x is equal to a negative 3. And then just divide by 8 on both sides, and we get x is equal to negative 3 over 8. All right, let's do one more with this one-to-one property. Let's do e squared times e to the x is equal to e to the 6th divided by e to the x. So already we can see that everything has the same base. Everything is a base of e. But in order to use the one-to-one property, we need just one term on the left and one term on the right. Right now we have the e squared times e to the x, so we need to simplify that. On the right, we have the e to the 6th divided by e to the x, so again, we need to simplify that. So here, just remember your exponent properties. So when we multiply, we add our exponents. So we get e to the power of 2 plus x on the left-hand side. And when we divide, we subtract our exponents. So we get e to the power of 6 minus x on the right-hand side. All right. And then since we now have the same base on both sides, we can just set our exponents equal using, again, that 1-to-1 property. So that would give us 2 plus x is equal to 6 minus x. All right, solve for x. So I'm going to add an x to both sides, subtract a 2 from both sides, which gives us 2x is equal to 4, and then dividing by 2 gives us x is equal to 2. All right, so there is one more example using this 1-to-1 property in the notes on Blackboard, so definitely go through and look at that, make sure you understand it. But we're going to end our video here, and in the next video we're going to look at solving exponential equations using the definition of a log. So keep watching.